Hello, this is Mr. Stansbury. I'm going to take you through the notes on the unit circle. Okay, at the end of this, you should be able to say I can find multiple angles with the same trig ratios. Okay, so let's first off talk about what the unit circle is. The unit circle is the circle with center at 0, 0. So this right here is right in the middle. That's the x-axis and the y-axis. And it has a radius of 1 unit. So from here to here is 1, here to here is 1. Any distance from the center of the circle to, the center of the circle to the edge of the circle here, all of these lengths here are exactly 1. Okay? Now, to measure angles, we always start at due east. So this is always our starting point, our start line right here. And if we get a positive number, we go counterclockwise. So this would be a positive angle here, and then a negative angle is starting here at due east and going clockwise, and that will give us a negative angle. All right. Definition of sine and cosine. So here's where we're going to get our trig ratio stuff in here. Point P, which this point right here is AB, okay, lies on the unit circle in quadrant 1. So this here is considered quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay? OP makes an angle theta, this theta here, with the x-axis. Okay? The sine of this angle here, sine is opposite over hypotenuse. So in this case, the sine is going to be b over 1, right there. Opposite over hypotenuse, b over 1. So the sine of theta on a unit circle is just going to be whatever the this b here is, which is the y value. Okay, so sine is going to be b over 1, which is just b, which again is just going to be the y coordinate of this point on the unit circle. Okay, and then cosine is adjacent over hypotenuse, so that's going to be this here, this a distance here over the hypotenuse, which again on the unit circle will always be 1. So cosine is just going to be this a value here, and so really cosine is just the x value of the coordinate on the unit circle. Okay, since a is the same thing as cosine theta and b is the same thing as sine theta, we know that a squared plus b squared equals 1. So a squared plus b squared equals c squared, and since we know that 1 squared is still just 1, so we know a squared plus b squared equals 1. That's what we have here, a squared plus b squared equals 1. Then we also know that if we take a is the same thing as cosine theta, so we take cosine theta in for a, and we get cosine squared theta plus, put the sine theta in for b, plus sine squared theta equals 1. Okay, and then this is one of our trig identities that we're going to talk about later on. Okay, so cosine squared plus sine squared equals 1. All right, next, supplementary angles. Two angles are supplementary if their sum is 180 degrees. Okay, so if this here is theta, well, this here is also theta. It's going to be, these are the same angles here. From here around to here will be 180 minus theta. So this angle and this angle will be supplementary, this angle and this angle will be supplementary, so forth and so on. Point P, again, instead of putting the x and the y, we now know that x is the same thing as cosine theta. So we're going to say point P is cosine theta, and then the y is the sine theta. Okay? P prime, this one over here, P prime is going to be the excuse me, as we make this little triangle here, I'm just going to draw this on here to hopefully help this make a little bit more sense. Okay, so here we go. So we've got point P here, and then we've got P prime. So the P prime has got the same y value. It's still going up however far the sine theta is. So the sine theta is the same for both of those, but instead of going to the right, from 0, it's going to the left. So that means that our x is going to be negative. So hence our cosine theta over here is positive, and the cosine theta over here is negative. Okay, so point P, cosine theta, sine theta. P prime is negative cosine theta and sine theta. Or we can say that P prime is cosine, instead of negative cosine of theta, so the opposite here, it's also just going to be the cosine of the supplementary angle to theta. So there's theta, and then here's going to be the rest over here. Okay, and then we can also have the sine is going to be 180 degrees minus our angle as well. So again, that sine will still be the same. Here's theta, and then here's 180 minus the theta. So really look at this as these are both thetas, but so again, the prime here, cosine, this one over here is going to be the cosine of 180 minus theta, and that's also going to be the sine of 180 minus theta. It's the supplementary angles over there. Okay. So the big thing we really want to get out of that is that cosine of 180 minus the angle. So the cosine here changes from positive to negative. So cosine changes from positive to negative. Sine, even when we're going this way or that way, going due east or due west, the sine will still be positive for both. So sine of 180 minus theta is still going to be the sine of theta. Okay, I'm going to give you some examples that will help this make a little bit more sense. But before that, let's do a little video comedy break.
Poor kids. Bedtime is a crisis. That's why I'm here right now. It's too hard. They act like they've never been to sleep before. Bed? What's that? No, I don't want to do that. Then it becomes some hostage negotiation, but in reverse. Look, if you stay in there, I will give you whatever you want. I will meet your demands. What do you want, a helicopter to Cuba? Anything. Just stay in there. There's always one awake. Like they're taking shifts. All right, I'll annoy him from midnight to 2. Who wants 3 to 6? Now let's lie down and practice kicking him in our sleep.
All right. Let's do this. Let's take a look at some examples here. So we're going to complete the following table. We're going to find the cosine of 8 and then the sine of 8, and then the cosine of 180 minus 8 and the sine of 180 minus theta, which in this case here is 8. Okay, so we're going to use our calculator to figure these out. Okay, so on your TI-84, you can do this on the scientific calculator just as well too, but I figured I'd try to show everything on the TI-84. First thing you got to make sure that you do is check your mode. What we need to make sure that we are in degrees mode. This one is almost all your graphing calculators are going to default to radians mode. So we got to go through and put into degrees mode. Second quit. And then we're back in business. So now what we're going to do is do cosine of 8. So cosine 8, push equals, and we get 0.99. Just so you can kind of get an idea what the heck's going on here, cosine is going to be, remember cosine from our angle, so this is our 8-degree angle right here. Cosine is adjacent over hypotenuse, so this length here to that one is 0.99. So that makes sense. This should be really long, and this one's going to be really short. Okay, so we get 0.99. Let's do that in a different color. 0.99. Okay, and then now we're going to do the sine. So that's going to be this opposite over the hypotenuse. So then we will do sine of 8, and that should be a really small number, 0.14. 0.14. All right. Oops, wrong spot. 0.14. Okay, now we're going to do cosine of 180 minus 8. So we can just do this. Cosine, it's already put parentheses in there. 180 minus 8 gives us negative 0.99. And then we will do the sine of 180 minus 8. And magically that gives us 0.13. 39, so 0.14. Okay, so this is turning out just like we had talked about on the previous page here. Let's see if I'll pull it up and see if it looks messy. Oh, it doesn't look a little messy, but cosine of 180 minus theta is negative cosine theta, and sine of 180 minus theta is regular old sine of theta. So if you'll notice, this turned to the opposite sign because it's now over here, right? And then the sign stayed the same because they're still both going up over there. All right, so with 33, so we can just go through and do all of these here. To save a little bit of time, I'm just going to go through and fill out the rest of this table, and we'll just kind of talk a little bit at the end as to what everything looks like. Because everything from what we're doing right now is just putting stuff in on the calculator. Okay, so here's what the table looks like all filled out. We're doing calculated all these, and again, notice that sine theta and sine of 180 minus theta, these two columns are always going to match. And then cosine of theta, and then cosine of 180 minus theta, these are going to be opposites, because again, one side's going this over here, cosine theta is going to the right, cosine negative theta is going to the left over here, so it's going to basically look like that. So that all that means is that this x over here is positive and this x over here is negative. But this y is positive and this y over here is still positive. Okay. Also note that once the angle gets past 45 degrees, which would be, just our perfect little 45, 45, 90 here, then once it gets past 45, the sines are bigger than the cosines, and when it's less than 45, the cosines are bigger than the sines. Okay. All right, that's all that we have right now for the unit circle. If you have any further questions on this, please feel free to ask in class. Thanks.